Let me now walk you through a fairly simple example of a linear differential equation to see how all the steps end up looking in a real application, in a simple real application. So remember, the first thing that we want to do is we want to put this equation in its proper form. What does that mean? Well, it has to be in the form of y prime. Uh-oh, we have a 2 in the denominator. Well, that's easy to eliminate. All we have to do is multiply both sides of the equation by the same factor, namely 2. This is, of course, one of the key tricks of the method of solution, but in this case, it's very simple. And that's actually all we need to do, because once we've multiplied both sides by 2, we have it in the proper form. We have it as y prime plus some function times y. The function in this case is just 2, very simple function, but that's okay. And then equals some function of x on the right hand side. Okay, now that we know that, we have to find the integrating factor. Well, remember, the integrating factor is given by e to the exponent of the integral of f dx. And who is x? Well, x is the coefficient in front of y. In this case, it is just 2, so we're looking for e to the power of the integral of 2 dx. Notice again how in these simple examples, and most of the ones you're going to see will be fairly simple. Maybe not as easy as this one, but it will simplify very nicely. And of course, so the integral of 2 dx is just 2x. And remember, all we're looking for is one antiderivative, not the whole family. So it's enough to say, all right, let's pick e to the 2x as our integrating factor. Now what we're going to do is we're going to multiply both sides of the proper form of the equation by I, and that gives us e to the 2x y prime plus 2 e to the 2x y equals 4 e to the 3x. You may want to pause and stop for a second about the algebra here, but that is correct. Now at this point we need to integrate both sides, but before we do that we may want to remind ourselves that the left hand side now has become the derivative of a product, right? That was the whole point of the proof. And in fact it is the derivative of the product of e to the 2x, which is the integrating factor, times y. And on the right hand side we have our function. Okay, now we integrate both sides, and the left-hand side is immediate. We're taking the integral of a derivative, so it's just the original function. And on the right-hand side, we have to compute the integral of whatever it is we're left with. Again, in this case, this integral is relatively simple, and turns out to be 4/3 e to the 3x plus c. Now, of course, we've integrated everything, so now we have to add our constant. Now this is already an implicit solution, but getting the explicit solution is very simple. All we have to do is multiply both sides by e to the minus 2x, or if you want, divide both sides by e to the 2x. And so we end up with our final solution, which is y equal 4/3 e to the x plus c e to the minus 2x. So notice once again, as we have done for separable equations, that integration constant c ends up in a fairly unexpected place. It's actually the coefficient of one of the two terms. Okay, so again, this is something that is going to happen very often in with differential equations, that plus c will end up popping up somewhere, and we don't know where. So we need to keep good track of where it is going. So once again, once you go to class, we'll do some more examples, and certainly encourage you to do many more on your own to make sure that you become familiar with the procedure.